We are still in net change as the integral of a rate. We're going to move that into some applications with velocity. So just quick definition, really. What is the distance between displacement versus distance traveled? Okay. Any ideas? Leon? Since you already know this, obviously. I already asked my question. What is the difference?
Distance travel is like you travel while your displacement. Yeah, it counts.
What?
Say like you were going somewhere and then you turn around and come back, and then how far you actually travel is your displacement. And then how far is even your turnaround and how far you came back.
Change in location from where you started.
Yeah. Okay. So displacement, you're correct, is the total distance. It's just your distance from your starting location. Even if you've gone far and turned back, it's just this distance. Okay. Distance traveled is going to be this plus this. Okay, that's distance traveled. So there are a couple of ways, or there's a way to distinguish the two, right? Because we're working with our position, velocity, and acceleration relationship. Okay, remember that. So best way to do it's an example. Okay, we're going to say a particle, this is a particle motion problem. The particle has velocity v of t equals t cubed minus 10t squared plus 24t meters per second. What is the displacement? From 0 to 6 seconds. So this is just the straight up integral. From 0 to 6. Because integral is the signed area, correct? So it's going to take out that negative distance. It's going to account for everything, and it's going to give us the total displacement. Somebody's having fun. You go ahead and calculate that answer, because I know some of us have struggled with the end result there.
I think he's finally lost his mind. Seriously.
We were talking about that just this morning, actually, both him and I. How's that integral going?
Pretty good. I think we
Start, got his map.
Yeah, just look in the book. What's the answer? I'm just kidding. You're struggling to remember that you take the integral and you put evaluate off the end of it. And then plug 6 into all of it. And then subtract and put 0 in for all of it, which is 0 in this case, thankfully. What do we get?
Would it be 12 t squared over 2?
36.
It's 24 t squared over 2.
Oh,
So it's 12. Yeah. 36 what?
wait, what's the next step after that? You plug in?
Meters. Okay. So displacement is very straightforward. Just integral. Bam. Right?
Displacement is the integral of velocity, always.
Yeah. Sometimes distance traveled is the same, but we have to, for distance traveled, we have to account where that turns direction. What's that called? Yeah, we need a critical point. Okay, so we're going to set that equal to 0, velocity equal to 0. And solve for where it changes direction. Okay, so algebra, factor a t out. Let me get,
With just the original equation.
yep. Because the change, if the velocity goes to 0, it indicates that we've stopped. We might have changed direction. So that's what we're looking for. Can we factor that? Yep.
And 0.
So 0, 4, and 6.
Not 0.
No, I didn't.
Around you.
Oh, pretty sure. Okay, do 0 and 6 matter? No. We're going from 0 to 6, so we're not going to worry about those. We're going to look at 4.
Wait, why are we looking for?
Because it's where the velocity goes to 0. We might have changed direction. Okay, so plug 3 in. Do we get a positive or negative?
Negative. That's it.
Positive.
Are you sure?
Positive.
Positive cubed.
Which one is it?
It's positive or it's negative.
Okay, so we have a sign change. There's a direction change at t equals 4, right? Here's how we account for that in the integral.
Was that a critical point now?
That's what we would consider it, yes. Okay, so the integral has to be from 0 to 4.
So how do you do the type 4 and not type 0?
6 and 0 are start and end points.
Oh.
We're not worried about it changing direction there,
Oh,
right?
okay.
That is definitely not something you need to, never mind. Okay. Okay, so our integral changes slightly. We know that this is positive right? But this is negative, so we have to subtract it. It'll actually end up adding that negative distance in, and we'll have our total distance traveled. Okay? And if you go through and do the work, you get, yeah, it's a 128. So if you go through and do the integral, you get those answers, 49 1/3 meters. So you can see that distance traveled is quite a bit longer than the other. Are you guys okay? Are we good? Any questions about yesterday? Okay.
25, I think.
25?
Yeah.
Yep. Okay, I can help you with that.